It feels like our corner of the cosmos is getting crowded. For months, it seems every other news report has been about another asteroid making a close pass, each one a faint reminder of the cosmic shooting gallery we live in. We were just getting used to the headlines about Comet 3I Atlas, a beautiful but distant celestial wanderer, but that was a story of cosmic wonder. This is one of cosmic dread. As if the steady drumbeat of near misses wasn't unsettling enough, astronomers have now confirmed a far more immediate and imposing threat. A colossal asteroid designated 2025 FA22 is barreling through the solar system on a trajectory that will bring it frighteningly close to home. Measuring up to 280 meters across, larger than a skyscraper, and carrying enough kinetic energy to obliterate a major city, this object is in a completely different class from the minor space rocks that typically fly by. On September 18th, it will make its pass, and while scientists project it will be a miss, the question that hangs in the air is as massive as the asteroid itself. In the vast, unpredictable mechanics of space, how certain can we really be? Here's the basic shape of the asteroid story. 2025 FA22 was discovered on March 29, 2025 by the Pan-STARRS 2 survey in Hawaii. Within days, it went from a faint moving dot on a wide-field image to a tracked traveler with a real orbit. The size estimate landed in that unnerving middle ground, roughly 120 to 280 meters across. Big enough to flatten a city, not big enough to be obvious until it was already fairly close. Public-facing headlines latched onto the scale, bigger than 3 football fields, but the real drama was Orbital. This rock was not hypothetical or way out past Mars, it was already inbound for a near pass we could put on a calendar. When and how close are the two facts everyone wants. The official orbit solution used by the International Asteroid Warning Network pegs the closest approach at 0742 UTC on September 18, 2025, with a missed distance of about 0.00563 astronomical units. That's roughly 841,000 to 842,000 kilometers, or a little over 2.2 times the Earth's noon distance. Close in cosmic terms, yes. Dangerous this time? No. That is why professionals call it a near miss and not an emergency. We can schedule the moment. We can point telescopes. We can show it to the world live. Dig one layer deeper and the orbit becomes a map you can feel. The IWAN page, mirroring the JPL Small Body Database entry, lists semi-major axis about 1.507 AU, so on average it lives closer to the Sun than Earth. Eccentricity about 0.415, meaning a stretched oval, not a neat circle. An inclination about 7.55 degrees, a modest tilt from the plane of the planets. This makes 2025 FA22 an Aton-class near-Earth asteroid, a family that spends much of its time inside Earth's path, occasionally crossing our orbit like a pedestrian stepping through traffic. The geometry term that quietly raises pulses is the MOID, minimum orbit intersection distance, listed around 0.00173 AQ, or about 260,000 kilometers. MOID is not a collision forecast, it's a lane width number. But when that lane is narrower than the moon's average distance, it means we are sharing a crowded crosswalk.
If this feels like it appeared out of nowhere, there's a reason. After Pan-STARRS logged the object in 2025, astronomers turned the clock backward and found pre-covery images. Older survey frames where FA22 had been captured years earlier but not recognized at the time. That historical breadcrumb trail tightens the orbit dramatically. In the very first days after discovery, while the arc was still short, some long-range solutions showed a tiny non-zero impact probability around 2089. There was even a brief Torino scale 1 tag, the lowest rung of public hazard messaging. With recoveries added, that line disappeared. Today's ephemerides show no impact in 2025 and no credible 2089 scenario. The story went from, we should check that, to, we're fine this pass, let's learn as much as we can. Learning is the point, and the playbook is already open. IAWAN has organized a coordinated observing campaign around the flyby. Optical recovery as the solar elongation improves, then characterization sprints, astrometry to show the position, photometry to watch its brightness flicker as it spins, spectroscopy for surface composition hints. polarimetry for texture clues, and radar if the geometry cooperates. The campaign notes advise observers that optical pickup becomes practical as the elongation climbs into the 40 to 60 degree range mid-September. Then things get interesting fast. The approach is a rehearsal by design. Treat a close but safe object like a dress rehearsal for a future one that isn't. Radar is the headline instrument because it turns a faint moving dot into pictures. NASA's Goldstone Planetary Radar in California scheduled time on FA22 across September 18th through 22nd, a window that begins just hours after closest approach. When radar hits, the asteroid sends back a time-delayed, Doppler-shifted echo that can be stacked into delayed Doppler images, blocky at first, then sharper as signal improves, revealing major axis length, elongation, concavities, maybe even a lumpy contact binary shape if two lobes are gently fused. Early planning notes talked about a moderately elongated body with a lower bound near 220 meters on the long axis. The radar tracks will confirm or correct that hunch. If the signal-to-noise cooperates, we can end the week with a 3D shape model your audience can see rather than imagine. If you don't own a radar dish, you can still watch the night do its work. Around closest approach, FA22 is expected to hover near magnitude 13 to 15, too faint for naked eyes, reachable for backyard telescopes with a camera, perfect for a public webcast. The Virtual Telescope Project has already posted the date, time, and link for a live stream that starts in the small hours UTC, so viewers can watch the asteroid crawl against the star field while numbers on screen update in real time. That mix, an object that you can see only with patience, data you can watch in a browser, it's Planetary Defense's quiet magic trick. It makes a distant precise and the precise public. Everything about FA22's geometry feels designed to teach. It is big enough to be worth radar. It is bright enough at peak to tempt advanced amateurs. It is close enough to be exciting, yet far enough to be safe. The missed distance, 842,000 kilometers, lands in that psychological zone where our language strains. A hair in space is still more than twice the Earth-Moon distance, and yet at solar system scale, it's a scrape. That weird duality is part of why these stories ricochet through social feeds. Close and safe sound like they don't belong in the same sentence until you see the unit labels change from kilometers to lunar distances to AU. Numbers teach humility.
And humility is exactly what the what if paragraph asks for. No one is predicting an impact this week. The orbital solution shuts that door. But the size class, hundreds of meters, is the zone where local disasters become regional catastrophes. History's cautionary tale is Tunguska, 1908, when something, perhaps 50 meters across, exploded over Siberia and flattened thousands of square kilometers of forest. Scale that up 2 to 5 times in diameter, and the energy grows by an order of magnitude or more. A land hit erases a metropolitan footprint. An ocean hit sends tsunami trains across basins. A poorly timed atmospheric entry can loft dust and water vapor high enough to nudge climate for months. This is not fear-mongering. It is the sober math of kinetic energy. The reason professionals get animated about a safe flyby is that practice and precision on days like this are the only reasons a future day doesn't go badly. Then we exhale. This time is a miss. 2 Longview lessons follow from that. First, time is the currency that buys easy solutions. The earlier we find a rock, the smaller the push required to turn a hit into a miss. Second, technique is a muscle. We strengthen it by using it. In 2022, NASA's DART mission rammed a spacecraft into the small asteroid Dimorphos and measurably changed its orbit. Kinetic impact proven in the real world. ESA's Hera mission is en route to survey the crater and physics in detail. The connection to FA22 is direct. Every radar frame, every light curve, every spectral line we recorded this week feeds the models that answer 2 blunt questions next time. How hard? Where? Planetary defense is not a movie climax. It's a decades-long habit of paying attention. By now, the asteroid chapter has done its work. We know what it is, how close it gets, why we care, and what we gain. Only then do we zoom out to the second notification, the interstellar comet that arrived as this asteroid story was building. 3I Atlas is different in every way that matters. Where FA22 loops around the sun on a repeatable ellipse, Atlas is on a hyperbolic track, a one-way through our system, never to return. Where FA22 is rock, Atlas is ice and dust that sunlight is beginning to wake. Where FA22 tests our defense, Atlas tests our understanding of how comets from other stars are built. And where FA22 rushes by at a distance we can analogize to the moon, Atlas will never come remotely close to Earth. It is a science story, not a risk story. The basics arrived fast. The Atlas telescope in Chile reported the discovery in July 1st of 2025. The Minor Planet Center confirmed the interstellar nature and the official designation, 3I Atlas, soon after. NASA's public notes emphasize the big ideas. This is only the third confirmed interstellar object we have seen, after Oumuamua in 2017 and 2I Borisov in 2019. Hubble has already imaged it, and the closest approach to the Sun will come in late October of 2025, just inside the orbit of Mars, before the comet fades back into interstellar night. No realistic mission can chase something discovered that late and moving that fast, so the plan is a full-court press with space and ground telescopes while it's bright. Atlas has already shown personality. In early September, astrophotographers caught it during a total lunar eclipse and reported a greenish hue brightening in the coma. Green in comets is usually a sign of dicarbon, C2 fluorescing under sunlight, though spectroscopists are still trading notes. Cyanide was flagged by some teams in August. Others want more data before calling the chemistry. NASA's public gallery includes the crisp July image at about 277 million miles from Earth, showing a teardrop cocoon of dust around a tiny icy nucleus. It's the sort of picture that pulls you in as the comet is slipping away. And that's the point. Interstellar visitors give us alien samples at a distance, clues about how planet-making works around other suns, read across light years in spectra and color.
So why do these alerts feel like they're arriving all at once? Partly because we upgraded the net. Surveys like Pan-STARRS and Atlas are wide-field, automated, relentless. The algorithms don't sleep, and they're tuned to flag anything that moves against the backdrop of stars. A-10 asteroids like FA22 lurk in the glare near the sun, where searches used to be weakest. Interstellar comets are faint, fast, and gone if you blink. We miss fewer now. The other part is simply that space is busy. Earth orbits in a neighborhood threaded by thousands of near-Earth objects of all sizes. Most are tiny and burn up. A few are city block big and pass within a handful of lunar distances every so often. Interstellar visitors are rare, but we have now seen 3 in less than a decade because we finally have the eyes to catch them. The sky didn't get busier, we did. If you're looking for a tidy moral, it's this. FA22 and 3I Atlas are not a coincidence to fear. They are a syllabus. The asteroid teaches logistics, how to coordinate observers, push radar, stream a near miss, and quantify what we would do next time. The comet teaches origins, how material from another star behaves under our sun, how ices spit out different molecules as they warm, how familiar our recipe for planets is compared to the galaxies. One closest distance without crossing a line, the other crosses our system without closing distance. Together, they turn a season into a seminar on attention. Take the next few days step by step. September 18th is the date to circle for the asteroid. The closest pass at 0742 UTC will be accompanied by charts and cameras, and if we're lucky, radar frames that paint potato-shaped silhouette sliding past the numbers on a screen. Then the spotlight shifts back to Atlas as the comet sinks toward perihelion in late October. Viewers will ask if either object is dangerous. The answer is straightforward, and not the least bit boring. No, not this time. The excitement is not fear. The excitement is signal. And that brings us to the verdict that threads both stories together. 2025 FA22 is the kind of object you want to meet on a day like this. Big enough to test every tool we have, close enough to justify the drill, far enough to let everyone sleep. The value is cumulative.
The astrometry that trims uncertainties, the light curves that time its spin, the radar that sketches its bones. 3i Atlas is the kind of visitor you hope to see once in a career. Proof that our solar system is not sealed, that raw, star-forged material wanders the aisles between suns, and that sometimes it wanders our way while we happen to be looking. A season that delivers both is not a scare, it is a systems check. Are our surveys catching what matters? Are our models sharp? Are our streams ready to show the public what a near-miss really looks like? If you want a closing image, imagine Earth as a runner on a dark oval track, keeping a steady lane, heartbeat loud in the ears. Some nights, a stranger cuts the infield, gliding across the grass and out the gate. No thread, only mystery. That's Atlas. Some nights, another runner brushes our lane on the straightaway, close enough that we feel the air of their passing. That's FA22. The right response isn't panic, it's posture. Shoulders down, eyes up, stride even, attention on the clock. Because the clock is what the sky gives us in exchange for watching. The seconds and minutes and years we need to move from luck to plan. So yes, the sky is buzzing. It's telling us we live in a neighborhood with traffic and that our tools are finally good enough to hear the hum. On September 18th, a rock the size of a city block will slide past at a careful distance, and we will practice seeing it perfectly. In late October, a comet from another star will skim the sun and fade, leaving pictures and spectra like postcards from a place we'll never visit. 2 alerts, back to back, same season. The universe isn't escalating. It's informing. We don't need to beg for a twist ending. We just have to listen long enough to understand what the data is quietly, insistently saying. The sky is busy. We are watching. And that is exactly how it should be.